So let's move on towards the deflection of cantilever beam by conjugate beam method. Conjugate beam method. Okay, so let's take a simple example. This is our cantilever beam. This is point A, point B. On the B there is a W loading and the span of the beam is L. So what we have to find out is slope at B and deflection at B. So two things we need to find out over here, and we'll be finding this by conjugate beam method. So first of all, conjugate beam method, what we have to do is the real beams bending moment we have to calculate. So bending moment diagram we know how to do it, so those who don't know will make a shortest step. So this is section XX where we have cut it at distance x from B. So the bending moment at x is equal to what? W into x. So bending moment at point B is equal to 0 क्योंकि L is 0. Bending moment at point A is W into L. So these are the values. So directly we can substitute these values into the diagram, and we'll make a small diagram of bending moment. So like this something the diagram runs. This is negative W into L. W into L. Yes, here it goes W into L. A end point, this is B point, and this is the L length of the beam. So this is our bending moment diagram of real beam. Now what we'll do is we'll make a conjugate beam of this beam. So what we have to do to make a conjugate beam, it's of same length but the free end becomes fixed and fixed end becomes free. So like this something. So this is free end and this is fixed end. So now this whatever loading is there we'll substitute on this. So okay, and the loading value will be m by ei times m is what? W into L, WL divided by ei, and this is our whatever is done is conjugate beam of cantilever. So now what we'll do, we'll find out the deflection and slope. So we'll find out the reactions and bending moment of this beam. We're going to find it out. So what we are doing is, so now this is our conjugate beam, something like this. This is B, this is A, this is length L, this is loading. This loading will be upward because the bending moment diagram is negative, so that's why the load is upward. Okay, so these are the properties of conjugate beam. You have seen it already. So next is ordinate WL by EI. Okay, as simple as that. So now let's solve this. So we have to find out the reactions at B. Before that, whatever the load is upward, so the reaction will be downward. So the reaction will be RB dash. RB dash directly the area of the triangle, half into length into WL by EI. So directly the RB dash value will be WL square by 2EI. And what we had told is the conjugate reaction whatever is there, the slope in the real beam. So theta B is equal to WL square by 2EI, because this slope in real beam is equal to reaction at conjugate beam. So now we have to find out the deflection. So deflection, for the deflection we are finding out the bending moment at B in a conjugate beam. So directly bending moment at B is equal to this triangle load into the CG distance. So load into distance is the bending moment. So for triangle it is CG. First of all, half into WL, half into WL by 2 EI is only a load, into multiplied by CG with CG. So CG from there it runs. What is CG from this? You know it. It's 2L by 3. It is CG formula. So please remember this. 2L by 3. So the answer becomes bending moment at B is equal to WL cube upon 3 EI. Thank you so much. So here ends the problem. Thank you.